Hello guys, welcome to codewithkazem.com. I'm Kazem. In this course, I will teach you about the yield in Python. Yield is one of the keywords in Python that has some application in Python programming. I will speak about the yield in Python in this course for you. At first, I will like to speak about the generator. But for understanding the generator, you need to understand the list or iterable variables. For creating a list in Python, suppose that L is a simple list in Python. It contains three elements, 20, 30, and 40. We can create a for in this list for I in L. For example, print the I. I save the code, print I, save and run the code. As you see, the Python print the elements of our code. For creating a list, we can use for in the loop. For example, suppose that we have L2 equal x multiplied by x for I in L. In here, we are creating a list that multiply each element by itself, and I print the L2. Excuse me, I must write here I. Print L2. As you see, this part of the Python code generate a list for our L2. If I print L2, as you see, it contains the every element in the L is multiplied by itself. In Python, a list is iterable. We have another variable in Python that is iterable. For example, if we create a string, for example, name1 equal to Kazem, it is another iterable variable in Python. Important point about the iterable variable, for example, list or string, is that we are saving all of the element of a variable in the memory of the computer. Suppose that I have a very big list. For example, all of these variables are saved in the computer. It is a range variable from 0 to 30,000. The all of the variable of n2 is saved in the memory. If you say n201, for returning the element of a list, we use this. For example, the first element in the n2 is 0, The second element is 1. It is a very big array or list of number that is saved in the memory. Uh, it is not very good for some application when you, for example, you want to read some number from the input. If you save all of the number into memory, the speed of your code is reduced. For finding the solution of this problem, we can use the generator. Generator or iterator, or we can say, I write here, generators. Generators are iterator, iterator iterators. They are a kind of iterable. You can only iterate over once. It is like a coin that every number are in a coin. When you call a generator, it returns a single value for you. In this way, all of the values are not saved in the memory. So the generator don't store all the value in the memory. They generate the value on the fly. Okay, for generating a generator, we can use, for example, my gen abbreviation of my generator is I plus I I cross I for I in range 30. Then for I or for X, I used X for as a different with the I in here. For X in my gen, print X. I save the code 2 and run it. As you see, it come here and it is a number from 0 to 29, and it multiply each element. Excuse me, say for simplification, I use 10 in here. Alright, as you see, every number is multiplied by 10. As you see, it is a similar to the list, but you cannot perform for X in my generator as a second time. You cannot use it, for example, in another loop, because the generator can use once in a Python code. Every time you call a generator, a new variable is generated from the it list. It doesn't generate all the value and save it in the memory. Every time you call a generator, a new variable is created. For better understanding the yield or generator in Python, I create another Python code. In this Python code, I want to write a function in Python. Suppose the name of the function is myFun. In this function, I have a range, for example, 2, 5, 3. Then for I in L, return 10 times I. If I save this code as a coded tree and run the code, if I must call this function. If I call the function or for example myFun, I call this function and run the code. It returns a value. If I n as the returned value of this function, as you see, n is 20. Why is it 20? Because when the function go to this line, it create a list, and the next list there is a for loop. In the for loop, it for on the all element of the list, and every element is multiplied by 10. The first element is 2. First element come and multiply by 10. Then we have a 20 and return the 20, and other number are not multiplied by 10. It is a function. For changing a function to a generator, we use the yield keyword. If I use the yield keyword in here and save it and run it, what is the n? N is a no, it doesn't return a value. It creates a generator for us. It is similar to changing the name of a generator. If I print the n, excuse me, print n, as you see, it returns a generator object. It is not a basic object. It is not a value, for example, similar to I. If we come here, type I, it returns 14. But when you print the value of n, the returning value of n is a generator object. Now we have created a generator just by using the yield keyword. For reading an element of a generator, we use the next method. Next method is internal method that there is in Python for generator. To underline, next, to underline, and parentheses open and close, and next value. But if I run the generator again with the next method, as you see, it returned 20, then multiply by 20, and if I multiply if I read again the next method, we have a 50, 5 multiplied by 10, and if I call the next method again, I have a 30. It means that 3 multiplied by 10. As you see, when you use a generator, you can access to the next value of a list. But in the first example that I used the return value as just access to the first element of output list. And yield is similar to return, but when you use a yield, you have a generator, and when you call the next method on a generator, you can access the value sequentially. But when you use the return, the program generate the output and you cannot go to the next value. So if you want to read 10,000 data from a database, if you read all the data and save in a list, then you will consume a lot of your memory. But when you use a generator, you just read an element from a database and you don't need a lot of memory to save your data. So if you want to optimize the memory, one of your way to optimize the memory is using the yield keyword. And the array for reading the element of a generator, as I said before, it is calling the next method, but you can use the next and the name of the generator, next, and return the next value, and next value. It is another way to reading a generator. In some application, you need to convert a generator to a list. How we can convert this generator to a list? And in this way, you don't need to call the generator every time. You just need to have all the value of output of a generator in a single command. How we can use it? You just need to write, for example, n2 equal list n. It will convert a generator to a list. I use this way to convert a generator to a list, but n is a variable that is assigned to the main generator, my fun. As you see, it returns empty list for us. But if you write n2 equal list and the original name of the list is my font. My font is the name of my generator. It returns a complete list of number. At now we don't have a generator, we have a list. It is a tricky method in the generator, All the example in here was the list of number, but we can define generator for a string. For example, this is a simple generator. Yield for first value I use the 1, and for second value I use, for example, custom, and for third you can use yield value as you like in your code, and 5. The third, this generator return 3 elements. All of them are a string variable. For I in, I write the name of the generator, and print the return value of this generator. As you see in here, the variable is string. My values printed for me, or I can convert it to comment, and we can create a function. We can call the function, for example, myg equal to simple generator. Then we can use the next, as you see before, next myg, next myg, next myg. And the end things about the generator is that there is expression in generator is called a stop iteration. When the generator get to the end value, it print the stop iteration. You can define in here if expression is a stop iteration, what does happen, and you can control on the stopping the iteration. Or you can we can define the class for generator. In the class of generator we must define the init and the next method for our generator. I will discuss this concept in the future video. Thank you for your watching.